The Story of Everything, Chapter 9, The First 378,000 Years, the Photon Epoch. Welcome to the first 378,000 years of the universe's history, my heavenly tour guide said. The Photon Epoch, during which the universe will grow to about half the size of the Virgo cluster. The temperature will fall from 300 million degrees Kelvin to a mere 3,000 Kelvin, or 5,000 degrees Fahrenheit, and the density will fall to far less than air. The universe is done baking, and this cake is a masterpiece. All it has to do now is cool off. What is the Virgo cluster, I asked, and why is it called the Photon Epoch? The Virgo cluster is the galaxy cluster nearest to the Milky Way. It contains about 1,500 galaxies. It's called the Photon Epoch because the final recipe of the universe called for about 1.4 billion photons for every proton or neutron, and because this whole epoch will be like living inside the outer part of the sun. Imagine we're inside the sun, but without the dense core, and that's the Photon Epoch. The whole universe was like one giant star during this epoch, just a big hot ball of light. Now that the universe is done baking, and will change very little over the next 378,000 years, other than getting bigger and cooler, it's time for a final inventory. Yes, I said, we have pretty much all the elements now to make planets and cows, right? She replied, well, you already know that we have more than 1 billion times more photons than hydrogen and helium nuclei, and about 70% the photon count of neutrinos and antineutrinos. There's also dark matter and dark energy, as you recall. By mass, the universe is now about 75.2% hydrogen and 24.8% helium, with 1 electron flying around for every proton. By count, there are 12 hydrogen nuclei for every helium nucleus. Oh, you've got to be kidding me, I said. That's all we have? Be patient, she replied. Everything we need is here, in potency. At least we salvaged 12% of the neutrons. That's all we need to make rock and roll and babies. And there's more than just hydrogen and helium. At the very tail end of nucleosynthesis, some deuterium and tritium survived, and even a tiny amount of lithium was made. So what's the final tally, I asked. Well, we have the 30 or so fields with all their ripples, aka the fundamental particles. The exotic particles and antiparticles have decayed away or have been annihilated, except for neutrinos, which have their own antiparticles. The particles left over are as follows. Far and away, the most abundant are photons, which are bosons, and neutrinos, which are very light matter particles that are so weakly interactive they can fly through a whole planet without hitting anything, and they don't even interact with their antiparticles. So we have just as many antineutrinos as neutrinos. We also have the other bosons, which you'll remember are the carriers of the fundamental forces. We have a blizzard of electrons running free because conditions are still too hot and energetic for them to bind to their atomic nuclei. We have the atomic nuclei themselves, or protons and neutrons, which, as you'll recall, are just 3 quarks and the gluons binding them together. And finally, there's whatever dark matter and dark energy are. In addition to space and time and the physical laws governing all things, that's the whole universe. As far as actual substances with structure, or what we typically think of as solid matter, The universe right now is just a big hot ball of hydrogen and helium plasma, just like most stars are. Plasma is basically a gas so hot that the electrons run free, resulting in a soup of atomic nuclei and electrons. We currently have 12 hydrogen nuclei for every helium nucleus, plus a few trace elements. By mass, we have 75.2% hydrogen, 24.8% helium, 0.01% deuterium, 0.003% helium-3, and 0.00000006% lithium. Those 5 substances are all the building blocks we need. I trust you, I said, although I don't understand how hydrogen and helium gas will become books and people. But I'm not sure I want to stay in real-time mode for the Photon epoch. I mean, if it's going to last 378,000 years. No, you don't, Sophia affirmed. To angels, that's an eye blink, but for humans, that's a little too long to wait around in a bright fog of searing hot gas. The moment she said that, the universe suddenly became a little less bluish, and Sophia became clearer in the fog, although we were still both enshrouded around the edges by a soft glow. What just happened? I moved us 3 years forward so you can see what the universe looked like when it was the size of the Milky Way. It's pretty much the same, I said. I just see light. She said, and it will remain that way through the entire epoch. The universe suddenly lost its bluish tint. Now where are we? We're at 47,000 years since the Big Bang. The universe is now about the size of the local group of galaxies, which is the 50 mostly small galaxies closest to the Milky Way. This moment is significant because the photons are now so diffuse that matter, meaning the hydrogen, helium, and lithium, is now determining how the universe evolves rather than radiation. We're really cruising along now, right? Sort of, she said. We still have a very, very, very long way to go before we even reach the first billion years. Let's go to 378,000 years and witness the end of the universe being basically a giant star, or the end of the Big Bang. Okay, I said, but let's actually go to 377,000 years to leave some time. Time for what? She asked. Well, now that we have nothing but time, true, well, let's just go there first. Okay, she said. We went to 377,000 years since the Big Bang. Everything looked the same, but the light was a bright amberish glow now rather than bluish. Sophia and I were still fuzzy with light, but the photon electron fog was definitely a lot thinner. I was amazed at how featureless and smooth the amber light was. There was no variation at all. Everywhere I looked, there was just this brownish-orange color. It was definitely not what I expected the end of the Big Bang to look like. Okay, I continued, we have at least 1,000 years to chat, right? Sure. Okay, well, I want you to finally tell me about the meaning of the heavenly things I saw. If God and the angels are actually invisible and don't have bodies, then their vision bodies must mean something. It's not yet time to speak of these things, but we will, Sophia assured me. You should learn in chronological order, and these things haven't been revealed to humankind yet because humankind doesn't exist yet. I protested, well, the Big Bang hasn't been revealed yet either. She said, the Big Bang isn't part of Revelation. Revelation concerns those things that the natural light of human reason cannot attain without divine help. The Big Bang is within the capacity of unaided human reason, if just barely. Right, I said, but the Big Bang hasn't been discovered by human reason yet because man doesn't exist yet. But let me finish, Sophia. I was growing impatient, though I instantly felt awful about being so bold with my gracious host. Nevertheless, my curiosity was insatiable, so I continued. And if it's knowledge you're giving me, well, anyway, if you're showing me the angels, because you're showing me history and they were there at the beginning of history, then you can show me what they knew. Sophia paused for approximately 1 Planck time in the evening light fog while she mulled over my proposal.